What I want to do here to start just for a minute or two is just kind of recap what we've done so far. Just kind of in a broad stroke sense, because we've been sitting here talking about quadratics for a minute now. We've done kind of a lot of things. I think kind of showing the connections and putting some context and everything will be a little bit helpful before we start moving forward again. So we started by talking about graphing. And we talked about there were 3 forms that we used for graphing. We talked about vertex form, intercept form, and standard form. And then we talked about how to convert in between those 3 forms. So vertex to standard, we expanded. Standard form to intercept form, we factored. Intercept form to standard form, we FOILed. And then standard form to vertex form, we used completing the square. And we've spent now some days talking about each of these 4 individual subskills. It turns out that some of these subskills, specifically completing the square and factoring, are things that we can use to talk about the next major topic here, solving. And it turns out that this solving I can use to do some things back in the graphing circle. So we're going to kind of come full circle here to kind of close out this chapter, just to give you a little bit of context about what we've done so far and where we plan on going. Everybody okay with that? That's very broad strokes, but I think it kind of helps connect some of these ideas back together again, because it's been some days since we've talked about graphing in particular, and that's kind of where we're circling back to here eventually. Okay. So that's kind of the little bit of a broad strokes of where we're planning on going still. But I want to talk about today is solving. And this will be a multiple day discussion about solving. So when we want to solve a quadratic, we're going to have several techniques that we can choose from. Some of these techniques will be pretty easy and kind of fast, but maybe don't work all the time for every single situation. Some of them might work all the time for every single situation, but might be a little bit more involved. So we'll kind of go slowly and carefully and talk about like the different situations and what you can do in a given situation. But today, the technique I want to talk about is called solving by factoring. So there's going to be several more solving techniques we'll talk about. Today, though, we're interested in solving by factoring. And this fits in very nicely as we've been talking about factoring for several days here. So this is just continuing on with like another thing we can use factoring to do. Solving by factoring takes advantage of this key observation here. So when we multiply two things together, and that product is 0, we know that the only way that can happen is at least one of those two things have to be 0, right? Because if I multiply two numbers together and get 0, the only way to multiply things together and get 0 is if one of them is 0. Or both of them could be 0, right? Everybody okay with that idea? We give this observation a special name. We call this the zero product property. And I abbreviate this often as ZPP because that's kind of a mouthful. So just to give you a symbolic example of what we're saying here. So if I have two things being multiplied together like x times y, and they equal 0, that tells me that x is equal to 0 and or y is equal to 0. This isn't true, though, for other numbers other than 0. So, for example, if I have x times y equals 1, well, x could be 1 and y could be 1, or x could be negative 1 and y could be negative 1, or x could be 2 and y could be a half, and you see that this goes on forever and ever and ever and ever. And there's no certainty about what we can say with that product. Does everybody see that idea? That's why equaling 0 is so very important to us. Okay. So that zero product property is going to be a key component in my procedure. So the procedure that we're going to use to solve by factoring is just going to be 3 steps. The first step is going to be to make the equation equal 0. So to do that, I just need to move everything onto one side. So I'm basically just going to add or subtract things from both sides until I dump everything onto one side or the other. Is everybody okay with that idea? We'll do some specific example in a moment, but this is, like pretty obvious on how to do that. The second step is to factor. And the last piece, or the last step, is to set each factor equal to 0 and solve. We're able to do that because of the zero product property. So that's how we're using that zero product property is step 3, is basically just applying that observation. So let's say we have the polynomial or the quadratic equation x squared minus 8x equals 9. And we're trying to solve this. Well, the first thing I'd want to do is, according to step 1, make the equation equal to 0. How can I do that? Subtract 9 from both sides. Everybody happy with that? Hopefully that's pretty obvious. So now the equation is equal to 0. The next step, it says, is to factor. So notice that this is a factoring problem where we can use our shortcut on because the leading coefficient is 1. This is one that I expect that you guys can eventually, soon, if not currently, be able to do in your head. What we're looking for are the two numbers that multiply to give me negative 9 and add to give me negative 8. What are those two numbers that do that? Negative 9 and positive 1, right? Everybody agree with that? So I can just rewrite this as x minus 9, x plus 1. And what symbol is going on in between these parentheses that we don't write, but is there? Multiplication, right? So, the third step then says I can set each of these factors then equal to 0 separately. Because I had two things that were multiplied together and equal 0, I can apply the zero product property. So I can solve the first one by adding 9 to both sides, and solve the second one by subtracting 1 from both sides. It's very nice now that basically this solving quadratic equation turned into just solving two linear equations, right? That's basically the procedure there. We use factoring to turn this quadratic solving problem into a linear solving problem. And I remember from our discussion at the beginning of the year, this was an area you guys felt pretty comfortable with from your Algebra 1 background as you spent a lot of time solving linear equations. But that's it. That's the idea. So what's the hardest step here? It's almost always just the factoring step, right? If you can get it equal to 0 and factored, everything else is pretty easy from there. Do you guys have questions about this process? Okay, good.